Okay, so let's continue. We're going to talk about something called rational exponents. All right, so you hopefully have read this. If you haven't, read it quickly. We're going to talk about how you can actually go between radicals, which we've just started working with again, as well as exponents with a fraction in it. All right, so if you ever see some base, whether it's a number or a variable, raised to an exponent that's a fraction, you can rewrite it using a radical. All right, so we're going to go between the two different ways. All right, the reason we're doing this today is because on Friday when we solve these equations, it might be easier for you to do these if you change it to one way or the other. All right, so you'll get comfortable with working with rational exponents. So again, that means there's a fraction in the exponent, which you probably have never seen before. All right, so let's look at this example. This is in a rational exponent form. See how there's a fraction in the exponent. So I want to write it in a radical form. So if it's in radical form, I'm going to need what? A radical. Okay, if it's in radical form, I need a radical. The denominator of the fraction. What is that denominator of this fraction? That is the index of my radical. So the denominator of my fraction is the index of my radical. Always. Okay? The numerator is what this whole thing is going to be raised to. All right? The whole thing's going to be raised to the first power. All right? Now, did I need to do that? No, because to the first power doesn't change anything. Where am I going to put the 64? In the radical. Now, another way you might see it in different textbooks or different texts for math, you might actually see it as the cube root of 64, and the first power will be right there. Okay, both of those are acceptable. Both of those are acceptable. Okay, now it says to simplify if possible. Do you know the cube root of 64? 4. Okay, and then what's 4 to the first power? Still 4. So there you go. So that's that one. Just 4. The cube root of 64 is 4. 4 times 4 times 4 is 64. Questions on going from a rational exponent to a radical? Well, now you guessed it. We got to go the other way. Now we have a radical, and we want to write it using a rational exponent. That means we need a fraction. All right? So I'm going to write a big 13. All right? Again, I'm going to put a fraction up here in the exponent. The 8 is my index. So is that the numerator or the denominator? It's the denominator. Which means the 4 is the numerator. So notice how they wrote it. They also could have written it as the 8th root of 13 to the 4th power. Those are the same thing. Okay? You can. So this would be 13 to the 1/2 power. So if I do the 8th root of 13 to the 4th power, that's the same as doing what? Is that 13 squared? No, that's 13, the square root of it. Right? Because the 2 goes here. I don't need to do the 1. So anytime you see something to the 1/2 power, that's the same thing as saying to do what? Take the square root. You're going to need to know that. All right? Especially when you move on to pre-calculus. Anytime you see something raised to the 1/2 power, it's saying to take the square root. Always. The answer is this, because it says to write it using a rational exponent. I'm showing that that is the same as that.